Lesson 44 is rationalizing denominators. So it's really similar to what we kind of have been doing. However, we're going to start dealing with square roots and something that I'm going to call the conjugate. We'll define that here in a little bit. So on example 1, we have 3 over 2 square roots of 5. And it wants us to simplify this down to where we don't have a radical in the denominator. Okay? So in order to get rid of the radical in the denominator, what we're going to do is we're going to multiply by the same radical piece there. So all we are is same thing. But really what we're doing is multiplying by 1 in a very special way. The way that we can do this allows us to not change the value of our problem. And ultimately what it does is moves the radical up top. So up top we just multiply straight across 3 square roots of 5. And on the bottom we get 2 times the square root of 5 times the square root of 5. Which when it is rewritten looks like this. Remembering this rule that says the square root of a times the square root of b is the same thing as the square root of a times b underneath the same radical sign. We can do this as 5 times 5, which simplifies down. I'm showing a lot of steps that you won't have to do later on. Square root of 25, which is actually just 5. Okay, so since that's just 5, it's actually just 2 times 5. So 3 square roots 5 over 10, so 2 times 5. So in real time, if you were going to write down this problem, you would go from this step to this step without anything in between. Okay, so I'll do another example that is similar to this. Let's say 5 over 3 square roots of a, no, let's not do 8. Let's do 7. Okay, so 5 over 3 square roots of 7. So in real time, when you're doing this, you're not going to show all of those steps probably. You're going to go really quickly. You're going to say, okay, I need to get rid of the square root of 7 off the bottom, so I'm going to multiply by 1 in a special way. I'm square rooting 7 over square root of 7, and I multiply straight across. So I get 5 square roots of 7. When I combine those, it is the square root of 7 squared, so those two cancel. I just get 7, and 7 times 3 is 21. So really, it's only a 2-stepper. Now, of course, if we can simplify 5 over 21, we would, but there's no commonalities there, so we can't. Okay? So let's do part B of that same thing. It says the square root of 1/8. Keeping in mind the kind of distribution that's going to happen here. You get square root of 1 over the square root of 8. What is the square root of 1? It's just 1. And then the square root of 8 we can't leave by itself. We can also simplify this down and put it in its simplest radical form. What perfect square goes into 8? 4 does. So I can break this down into the square root of 2 and the square root of 4. Right? And we all know the square root of 4 is 2. So we get 2 square roots of 2 on bottom. So all I've done right now is wrote it in simplified form. Now I have to get rid of this square root off of the bottom. In order to do that, I multiply by 1 in a very special way. The square root of 2 on both sides. 1 times the square root of 2 is the square root of 2. Do not write 1 square roots of 2. Okay, you don't have to write that out. In simplified form, it is 1 times square root of 2 is just the square root of 2. Okay, and then on the bottom, square root of 2 times square root of 2 just gives me 2, and then 2 times 2 is 4. And that's as simplified as it can get. And I know somebody's wanting to reduce this down to square root of 1/2 or something. Don't do that, okay? Yeah, we'll do another example. Go ahead. Okay, we have some more examples to go through. But before we do that, we need to go over the rule of conjugates. Really, the conjugate is just, let me just do an example. They have a radical rule right there explained. It's really kind of hard to read whenever you do it. Okay, so I'm just going to do the example and then explain it here in a second. Okay, so on example 2, they give us 2 over negative 4 plus the square root of 3. So what I'm going to do is I'm still going to multiply by 1 in a special way. But what a conjugate allows me to do is to know what I'm multiplying by. Okay, so here's what a conjugate is. It's the exact same first and last terms, but we're going to change the sign in the middle. So here I have a negative 4, and I have a square root of 3. Because this is plus here, I'm going to put a minus right there. And this helps us out a lot here in a second. So because I'm multiplying by 1, I have the same thing on top. It'll cancel some stuff out here in a second. But the conjugate is the first and last terms are the same, but we have different signs in the middle. Okay? Conjugate just changes the middle sign. Okay? Now, what this allows us to do is, on the bottom, some stuff cancels out. So we're going to deal with this kind of like FOIL. Okay? So we had this example when we were doing that practice ACT problem. It's negative 4 times negative 4, which gives me a positive 16. Negative 4 times a negative 4 square roots of 3 gives me a positive number, which is 4 square root 3. Okay, and then I'm looking on the inside here, I get a negative 4 square root 3. And this is why we had to have that negative, because we wanted these two signs to be different. And then we do the back side, which gives us a negative square root of 3 times square root of 3 is 3. Okay. Now, Taylor asked, why did we change the sign? The reason we changed the sign is because we wanted this to cancel. Okay? That's why we changed the sign. This is the difference of two squares, but broken down separately. When we get these down to the actual problem, it is the difference of two squares. Okay, and then the top, we just distribute that out like normal. So you get negative 8 minus, we can distribute that out, 2 square roots of 3. Okay, then I just rewrite it in the simplest form that I can. So the top will stay the same, negative 8 minus 2 square roots of 3. And on the bottom, all I'm left with is 2 whole numbers. So 16 minus 3 is what? 13. Can I reduce anything? No, because 13 is prime. Okay, so there's your answer. Negative 8 minus 2 square roots of 3 over 13. So to go back to that rule that says the radical conjugate, it gives you this complicated idea. So it says some number times the square root of b plus some number times the square root of d, as in delta. Then it gives you what the conjugate of it is. So all they did was rewrite the exact same thing, some number times the square root of b, and then they changed the sign in the middle. And then some number times the square root of d. So the reason I don't like this is because it looks really complicated, but in reality all you are is changing the middle sign. Okay? That's all you're doing. Just changing the sign in the middle. From a plus to a minus or a minus to a plus. Okay? So that's your general rule of thumb there. Let's do another example. This is example 2b. Gives us 3 over the square root of 5 plus the square root of 2. I have to multiply by 1 in that special way using our conjugate. So I still have the square root of 5 and I still have the square root of 2. What is my middle sign going to change to? A negative or a minus, right? So now that I'm multiplying by 1, all I have to do is follow my general rules of distribution and FOIL. So I'm going to do the top first. I'm going to distribute out this 3. I get 3 square roots of 5 minus, and then I'm going to distribute out 3 to the next piece, 3 square roots of 2. And you'll start to notice, and you'll catch on to some tricks of conjugates here in a little while. We get the square root of 5 times square root of 5, which is just 5. Then I get the square root of 5 times the square root of negative 2 negative, which we need to make sure we remember that negative there. It gives us negative square root of 10. When we do the inside, we get positive square root of 10. And you'll notice again, those cancel away. Then I do the last numbers and I get minus square root of 2 times square root of 2 is 2. So really, if I know that I'm multiplying by a conjugate, we only end up dealing with the front and the back pieces. Okay? So 5 and 5, and then the 2 and the 2 made that piece right there. And then it's just 5 minus 2 after that, which is just 3. Now this part is where it gets a little more complicated. Are there any questions leading to this piece right here? Not yet. Okay, I notice that in the top I can factor out a 3. Okay, there is a 3 in each of these. If I use my distribution properties here, I can rewrite it as 3 square roots of 5 over 3 minus 3 square roots of 2 over 3. And then those would cancel out just like that. And I'm left with a simple answer, which is the square root of 5 minus the square root of 2 as my final answer. Now do I have questions? Okay, what are they? Which step around here? Very last one. You said you take the 2 and do what? I did just to explain it, but in reality, let me rewrite that out. 3 square roots of 5 minus 3 square roots of 2 over 3. What you're really doing is you're factoring out the 3, just like that, and you're left with square root of 5 minus square root of 2 over 3, and then those 3's cancel. So the way I did it here is it was just easier for me to explain in that small area, but they're equivalent. You can do them either way. Or if you, I would just have left it. If we wouldn't have distributed this at the beginning, then we could have just canceled at the end. But I didn't know at the beginning, so. Squared away there? Okay, last example, and we can do more if we need it. It's kind of a bare bones foiling concept expanded into radicals. So here we have 4 plus the square root of 3. Now this is not a monomial. Before, all we dealt with was monomial, single term things. But on this one, this is a binomial, it's got 2. So it's going to be a little more complicated than the last one was. We're still going to multiply by the conjugate of the denominator. We only multiply by the conjugate of the denominator because we want to get rid of the radical from the bottom. We don't mind if the radical is in the numerator. We want it to be out of the denominator. So my conjugate will be 2 plus 3 square roots of 3. And on top, it will be the exact same. Okay, so I'm multiplying by 1 still in a very special way. So going from here, I still have to do FOIL because I have 2 terms now in each of those. So I get 4 times 4 times 2, which is 8, and then 4 times 3 square roots of 3. Now pay attention here because I'm afraid that you might get this a little confused. You're only multiplying the front number here because you can only multiply things underneath radicals together if you're going to do a radical. So it'd be 4 times 3, which is 12 square roots 3. Okay? On the back side, we start with 2 square roots of 3. Whoops, why did I write it equals? That was supposed to be a plus. 2 square roots of 3. And then the back piece, we have 3 multiplied. Okay, I wanted to show you. This ends up being 3 multiplied by square root of 3 times the square root of 3. Now the square root of 3 times the square root of 3 is just 3. Okay, so it ends up being just 3 times 3, which is 9. Okay, so I'm going to put the 9 in there. Because of the 3 up front. This is 3 square roots of 3. Right? Alright, I have a common last name, for lack of a better way. So I'm going to combine the things that are the same. So I'm going to square off these square roots of 3 here. And then I'm going to circle the regular numbers, because I have to combine those. I got to erase this because I'm going to run out of room. Okay, so I've done that. That way I can move on to my next step. So here I have 8 and 9, which together make 17. I have 12 square roots of 13 and 2 square roots of 13, which make 14 square roots. Or sorry, did I say 13? Square roots of 3. I'm sorry. Square roots of 3. So when I combine it all together, we only get 14 square roots 3 plus 17. And I'm going to leave that alone for the time being. Okay, I have to do the bottom still. So keeping in mind our conjugate rule, remember I told you that the middles will always end up canceling out. So all I need to deal with is the first pieces, which is 4, and the last pieces, which is always going to be a minus, by the way. So we get 3 square roots of 3 multiplied by 3 square roots of 3. So looking at the front pieces, I get 9. Looking at the back pieces, I get 3. And 9 times 3 is 27. Okay? 4 minus 27 is what? Negative number? Negative 23. Now, if there is no common thing that I can pull out because 17 is prime, then that's the end of my answer. I just circle it, or square it, whatever you do. Now, does anybody want to see another example? I'll let you choose one from the lesson practice. I would suggest C through E, one of those. Want to do E? Okay. So we have E from the lesson practice. The problem starts out 3 plus the square root of 5 over 1 minus the square root of 5. And I'm going to multiply by the conjugate of the denominator. So I get 1 plus the square root of 5. Do you have any questions over conjugate? Is that one fairly obvious? Always just change the sign in the middle. Right. After that, if it's a binomial, meaning it has 2 terms in the top and the bottom, it's just factoring, or sorry, foiling, not factoring, foiling. So maybe I'll do the denominator first, because I feel like the denominator is the easier of the two. So remembering, since this is the conjugate and the middles cancel out, all I need to deal with is the firsts and the lasts. The O and the I end up canceling each other out on the FOIL. Okay, so I get 1 times 1 is 1, and then I get a negative and a positive multiplied together, give me a negative every single time. So I get the square root of 5 times square root of 5, which is just 5, which will reduce down to 4 at the end, but I don't know how long my top part is going to be, so I'm going to way off. Okay, up here I go first times first is the first, so I get 3. Then the outsides, and I get 3 square roots of 5. Insides, I get 1 square root of 5, so it's just the square root of 5. And then I have the last, so that's the square root of 5 times the square root of 5, which is 5. Positive. Okay, combine the things that I can. So I'm going to circle my regular numbers. I will square my square root pieces that have the same radicand, which is 5 in this case, and I'll combine them. Okay, so I have 3 square roots of 5 and the square root of 5, which makes 4 square roots of 5. Then I'm going to look at my 3 and my 5, and I get 8 when I put those two together. On the bottom I get 1 minus 5, which is a negative 4. Now I can pull something out of this, so I'm going to factor the top piece out. What can I factor out of 4 and 8? I can factor out 2, I can factor out 4. So I'm going to factor out 4, open my parentheses. When I factor out 4 out of 4 square roots of 5, I'm left with just the square root of 5. When I factor out 4 from 8, I get 2. And on bottom I have a negative 4. The 4's cancel out. I do not want to lose my negative. So I have a negative. I'm going to go ahead and distribute it out here in a second. Square root of 5 plus 2. So I'm going to go ahead and distribute it out, and my final answer will be negative square root of 5 minus 2. Sorry I had to write that so small. But I have to distribute out my negative, so I get a negative square root of 5 minus 2 is my final answer. Yes? No, it doesn't. You can put negative 2 minus the square root of 5. Is that what you're saying? Yeah, that's fine. I normally put my radical piece up front. The book will probably put the radical piece in the back. It's really up to you, I guess.